Hello everyone. Today let's solve the problem, hard problem. So here this was asked in the Codeforces round 367 division 2. So let's see what the question states. You can just go through the question. It is very easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem, right? So what the question states here, a guy named Vasily has n strings. So just give me a second, 1 second here, 1 second. Yeah, a guy named Vasily has n strings, and he can reverse any string at the given cost. He can reverse any string at the given cost, right? So a guy named Vasily has n strings and can reverse any string at a given cost. He wants the strings in lexicographical order reversal, using only reversal. He wants the string in lexicographical order, right? So this is very important. So what the Vasily wants here, he wants the string in lexicographical or this one order by using only reversal. By using only reversal. This part is very important. What we need to find then? We have to find the minimum total reversal cost to make the sequence sorted. We have to find the minimum total reversal cost, right? So we have to find the minimum total reverse cost. Total reverse cost, right? So this is important to make the sequence sorted. So if it is impossible to do so, we have to return -1. If it is impossible to do so, we have to return -1, right? So reversals allowed and swaps are not. Reversals are allowed, but the swaps are not allowed. So this we have to keep in mind. Right? Right. So I hope the question is completely clear. This is very easy to understand. I'll just read out the question loud so that it will be easier for us to further go with the approach and other stuff. Right. So here Vasily has n strings and can reverse any string at a given cost and can reverse any string at the given cost, right? So he wants the strings in lexicographical order using only reversals. What we need to find, we have to find the minimum total reversal cost. We have to find the minimum total reverse cost to make the sequence sorted. So if it is impossible to do so, then we have to return -1. If it is impossible to do so, then we have to return -1. Reversals are allowed, but the swaps are not allowed. We have to keep this in mind, right? So let's come to the input part. So just give me a second here. Yeah, so here you can clearly see we have two, 1 2 BA and AC, right? So here uh, BA and AC are the strings. BA and AC are the strings, right? So we have been given two inputs here. This one, we have been given two inputs. They have strictly said that. So here we have been given 1 and 2, BA and AC, right? 1 and 2, BA and AC. 1 is nothing but this one. What do we call? We have to try with different combinations, right? So these are nothing but the strings. BA and AC are nothing but two strings, right? So the output that we need to get here is 1, nothing but here the minimum cost we need to find, right? So minimum total reversal cost to make the sequence sorted, right? That's what we need to find. Here it is 1, right? Here this is 1. Let's consider the same thing for the approach. You'll get to know how we got the output 1 basically, right? So here the same thing, we have the three inputs here, means AA, BA, AC, and the output that we need to get here is 1 as well for the second input or the second example. Let's go with the third example here. Same thing, we have the two inputs, triple B and this one, 3 times A. 3 times B and 3 times A, we need to get the output -1 here. So because it is impossible to get the minimum total reversal cost, right? So we have, in that case, we have to return -1. Same goes with the example 4 as well. It is impossible to get the minimum total reversal cost, right? So here also we have to return -1. So the input we have here is 3 times A and 2 times A, right? So I hope this part is completely clear, man. What we need to do is completely clear, basically, along with the question. Right now, let's do one thing. Let's discuss the approach followed by the complexities, and then let's write the code. Here I have considered the same first example that they have given in the question, right? So here we have been given two inputs. One is BA and BC, and the output that we need to get here is 1. So first thing that we need to keep in mind here is we will be going with the priority queue with the greedy with priority queue approach, right? So just keep this in mind. We'll be going with the priority queue with greedy. So let's move on with the step-by-step explanation. The same input we are considering for this, right? So strings we have is BA and AC, BA and AC, right? So as the input, two inputs we have BA and AC. So we have in the question they have strictly mentioned that Vasily has n strings and he can reverse any string at a given cost. He can reverse any string at a given cost. Also, he wants the string in lexicographical order by using only reversals. They have mentioned he wants the strings in lexicographical order using only reversals, right? So here, when we can reverse, he wants the string in lexicographical order using only reversals they have mentioned in the question. So reverse option, this would become AB and this would become CA. This would become CA, right? So reverse options, this becomes AB and CA. So let's try it out with the different combinations now. Let's try out with the different combinations, sorry. So BA becomes AC, so this is invalid, right? BA becomes AC, this is invalid. This one we are considering, man. BA and AC, right? Directly. BA and AC we are considering, this becomes invalid. Now let's consider the reverse of BA. Reverse of BA is this one, AB. We can reverse, right? Accordingly with the question, right? AB. So now AB and AC we have. AC we haven't reversed, only the reversed portion of BA we have considered here. AB reverse of BA, and we have considered along with the AC. Now we have the valid with the cost one. Valid with the cost one means we have got the minimum total reversal cost to make the sequence sorted. So this is sorted AB AC, right? So we want the string in lexicographical order using only reversal. So this is in lexicographical order. This is in lexicographical order. Also, we need to find the minimum total reversal cost to make the sequence sorted. So here we have reversed only BA. We haven't reversed AC. So there was only one step, right? So I mean to say the minimum total reversal cost is only one here in this case. We have reversed only BA to AB. Now AC remains constant. Now this is in lexicographical order. We have the minimum total reversal cost is 1, right? Minimum total reversal cost is 1. This is this one lexicographical order, and the minimum total reversal cost is 1. So now the valid with cost, so now this is valid with the cost 1, right? So the minimum total reversal cost is 1 for this output. So the minimum total reversal cost is 1, or the final output is 1 for the input or the example that we considered, right? So the output that we got here is 1, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct. So this is it for the approach. This is it for the approach, right? So our approach works absolutely correct for this example, right? So our approach works absolutely correct. Now as we are completely familiar with the approach, let's move on with the complexities part. So what will be the time complexity here? The time complexity would be big O of n into 2 into logarithmic n. N into 2 into logarithmic n for the code that we'll be writing in the future, right? So why it is big of n into 2 into logarithmic n? Because each of the two states per index is pushed into the priority queue. Each of the two states will be pushed into the priority queue. This you will come to know when we write the code clearly, man, right? So each of the two states per index is pushed into the priority queue, and priority queues are this one. Basically, time complexity when we make use of the priority queue would be because of logarithmic n, because this one logarithmic n, right? So here uh, each of the two states per index will be pushed into the priority queue, so it will be n into 2 into, so total this one, what do we call, priority queue operations are logarithmic n, right? So this will be overall n into 2 into big of logarithmic n. I mean big, this one big of n into 2 into logarithmic n. Let's write this one big of n into 2 into logarithmic n. So this is fine. What would be the space complexity here? Space complexity would be big of n. Why it is big O of n? Because we have to store the original as well as reverse strings and also the visited state so that we don't visit the same states again, right? So we have to store the original, reverse strings and the visited states, which will lead us to the space complexity big O of n, right? So the time complexity and the space complexity of the code that we'll be writing in the future would be big O of n into 2 into logarithmic n and big O of n, right? So I hope the complexities part is completely clear along with the approach. As we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So now let's start writing the code. So I'll just come here to the compiler. First, we'll be making use of the fast input output and this one, fast input output, right? So let's import this one, Java input output package. So I'll just go with this one. And also we'll be making use of the utilities. So I'll just go with Java util start. This is fine. Next, let's go with the class name here. Just give me a second. So I'll just give here string sorting. String sorting. So within this class, what we'll be doing? Let's go with the state to track the current index, cost so far, and whether string is reversed or not. Right. So I'll just go with here static class state. So I'll just go with this one implements. So let's go with comparable here. Yeah, comparable state. So we have considered state here, right? So within this method, so what we'll do here, so let's consider cost, position as well as the version, right? So original is 0 here, 1 is reversed. Version will be considering, right? So we'll be considering cost, position as well as the version. Version, in the version 0 is original and 1 is nothing but the reversed, right? So I'll just go with long cost here. So in positions, and the third one is in version. So this is fine. Let's go with the further things. Let's move on with the further things. So I'll just give here state. Parameters will be cost. So whatever we considered here, initialization part, sorry, this one. Uh, so this will be in positions. So position, sorry, and the final one is version. So this will be int version. So this one I'm speaking of. This is fine. So within this one, let's initialize cost, position, and version quickly. So this one will be this dot cost equals cost. This dot positions. So this one, let me make this one position instead of positions. So just give me a second here. Yeah, this dot position equals position, and the final one is we have version. So this dot this will be version equals version. This is fine. Let me come out of this one entirely, right? So for the minimum heap, uh, so we will be going with the minimum priority queue or minimum heap. So this is whatever I'll be writing the compare to method. This is for the minimum heap based on the total cost. So let me make use of the annotation, this one override here, override. So this is fine. So let's go with here public int. This will be compare to. So comparable compare to. Let's make use of compare to. Let's give the another name. So this will be state. So I'll just give other here. So this is fine. Within this, I'll just return so long. So let's make use of the compare here. So let's go with the cost as well as other dot cost. So this is fine. This is just for the minimum heap or the minimum priority queue based on the total cost, right? So let me come out of this one entirely. Let's come out of this one entirely. Let's go with the main function or the main method here. So I'll just go with here public static. So this has to be static void main. So this one will be string arguments. This is fine. So within the main function, so we will be going with the scanner. So I'll just go with the sc new scanner. This is fine. This will be system dot in. This will be system dot in. So let's go with the number of strings as well as the cost of I to reverse the ith string. Means this will be n equals sc dot next int. This is fine. And also we'll be going with the cost of I to reverse ith string. Means I'll just go with long costs here. This will be new long of, and this is fine. So the next step, let's move on with the further steps. Let's go with the iteration. Let's go with the iteration because we have to read all the reversal costs, right? So we have to read all the reversal costs accordingly with the approach. So I'll just go with for I equals 0 less than n I plus plus. So within the for loop, we have to read all the reversal costs. So this means iterated value of the cost will be, we have to assign this one to the next long. Next long. This is fine. So I'll come out of the for loop entirely. Next is we have to go with the original strings as well as the reversed versions. Both we have to consider, right? So I'll just go with the string here, variable name strings. Let me assign this one to new string of within the array n. The same thing. Let me copy the same thing here. Let me paste it over here. Instead of the strings, I'll consider a reversed. So we are considering the original strings as well as the reversed versions, right? So here this remains same, new string of n. So this is fine. So the next step would be, let's go with the for loop. Let's move on with the iteration part here. So this will be int I equals 0, again I less than n. So this is fine, right? Yeah, I plus plus. So within the for loop, what we will be doing, so just give me a second here. So within the for loop, what we'll be doing here, so we have to go with the original string as well as the reverse string again. We have to go with the original string as well as the reverse string again. So somewhere we have already done this one, right? No? Yeah, this is fine. So let me write here strings, iterated value of the strings. So this one say dot next, right? Say dot next. This is fine. This is nothing but the original string, and also we have to go with the reversed version. So I'll just go with reversed of I. This will be new. Let me go with the string builder here. So this will be strings of I dot, we have to reverse, right? So we have to reverse. For reversing, I'll just make use of the reverse operation that is provided by the string. So this one again we have to go with the toString. So this is fine, toString. Yep, we are going with the reversed version of the string because we have to calculate the minimum cost, right? Minimum total minimum reversal cost. So I'll just come out of this one entirely for loop. So we are done with the this one previous step. Means we went with the original string as well as the reversed version. After doing that, as I've said, we'll be going with the min heap or the minimum priority queue for the greedy state exploration, right? So we will be going with a Dijkstra style, not entirely, but we'll be making use of the priority queue. We can just consider this one. We'll be going with the Dijkstra type basically, right? So we'll be making use of minimum heap or the minimum priority queue for the greedy state exploration. So I'll just go with priority queue here. So this will be priority queue of state. We have already considered here. Where is state? State. This is fine. I'll just consider the variable name PQ. This will be priority syntax. So this is fine. So the next step is, as I've said in the approach, we will be making use of the visited so that we don't visit the same thing again, right? So I'll just go with here. This would be Boolean basically, right? So I'll just make use of the variable visited. Let me give here new boolean n, and this I'll just keep 2 within the array. So this is fine. The next step is we have to start with the first string in the both forms, means no cost for original and reversal cost for the reversed. So we have made use of the priority queue. I'll just go with pq dot offer. This will be new state 0 comma 0 comma 0. This is fine. 0 comma 0 comma 0 means this is the original form. We have to go with the reversed form as well. So I'll just copy the same thing and make the necessary changes for the reversed form. So I'll just come here. Let me paste it over here. This will be new state of this one. I'll just go with the cost or costs. Let me go with the costs here. Costs of, so not costs here. This will be cost. This is fine. Just give me a second here. So instead of this one, this has to be within the array initially. Cost of 0 comma 0 comma 1. You're going with the reversal, right? So this is fine. So this is nothing but the reversal form. After doing this, let's move on with the further things. Let's go with the this one simple while condition. So priority queue shouldn't be empty, right? So while pq not of pq dot, let me make use of the is empty operation. So then we can move on with the further steps. First, what shall we do? Let's pick the state with the minimum cost here. So I'll just go with the state current equals pq dot poll, right? So we are just picking the state with the minimum cost. We are just picking the state with the minimum cost. We have to uh, return the minimum cost, minimum reversal cost itself, right? So we have to pick the state with the minimum cost itself. So we are done with this step. Next step is we have to skip the visited. We have to skip the visited part, means we don't have to visit the same thing again and again, right? So we have to skip the visited. That is the reason we have made use of the visited variable here. So which consists of the boolean, if you remember line number 42 I'm speaking of, right? So here, what shall we do? Let's skip the visited. Let me make use of the simple if condition here. So this one, if visited of this one current dot, we haven't made use of the position. So this one has to be current dot position and also current dot version. So then what shall we do? Let me go with the continue here. Let me go with the continue here. We are just skipping the visited, and also we are setting this one to true. So this one visited, once we visit, we will set that position to true, right? So we will go with current dot position current. So I would have copied the previous line. This one, this is fine. Current dot version. This one, let's set this one to true. This is fine. So the next step is if we have reached the last string successfully, then we have to return the cost. Then we have to display the cost and return nothing, sorry. So for that one we need to write the uh, we need to implement this one in the form of code. So this one I can write it in this way: current dot position, this one equals n minus 1, nothing but if we have reached the last string successfully, right? So here uh, then I can just print here. I'll just go with system out println here. This one will be current dot cost. This is fine. So we don't have to return anything yet. So I'll just give return here. This is fine. So let me come out of this one entirely. If condition. So just give me a second here. So here, next thing is let me go with string. We need current string here. So I'll just go with the current str is fine. So this one, if current dot version, if it is 0, let's go with the simple ternary operator here. Ternary operator. So this will be uh, strings current dot position here, or reversed. So this will be reversed of current dot position again. So this will be reversed of current dot position. This is fine. So next, let's go with the next position here. This will be next position current dot position plus 1, current dot position plus 1. So this is fine. The next step is we have to try the next string in original form if if it is lexicographically valid, then we have to try the next string, right, in the original form. So let's write the simple if condition for that. So this one will be if not of visited, this one will be next position we have to consider. So this will be 0, along with it current string dot, let's make use of the compare to. So here I'll just go with compare to. This will be strings next position. So this will be if it is less than or equal to 0, then what we will do, let's go with the, we are making use of the priority queue. So I'll just go with pq dot offer. This will be new state. So this will be current dot cost comma next position comma 0. This is fine. So the next step here would be we have to try the next string in the reversed form if it is valid. So this will be if not of visited. So this will be next position. So this is 1 and current string current is, yeah, this one. Again, let's make use of the comparator. I would have copied the same thing and made the necessary changes. So this is for the reversed basically, right? So this is for the reversed, except this is for the reverse. So I'll just go with the reversed. This will be next position, next position. So just give me a second here. Yeah, it's less than or equal to 0. Then what we'll do, again same thing. Let me copy the same thing and make the necessary changes here. So let me copy this one. Let me paste it over here. This will be pq dot of a new state. So this will be, instead of this current cost remains same here. This is fine. Current cost plus this one, instead of the next position also we want, I think. Yeah, next position also we want. So this one will be cost of next position along with the next position, and instead of 0 we need 1, right? So we are going with the next position, right? So we have to give 1 here. This is fine. So let me come out of this one entirely. Let me come out of this one entirely. So next, the final part is if no valid path is found to make sorted, then we have to print -1 that they have given in the question. This is one of the edge cases, right? If no valid path to make it sorted, then we have to print -1. So I'll just go with here println system out println. So here this one will be -1. So this is it for the code. So this is it for the code. So before trying this one with the different inputs, before trying the code with the different inputs, I just want to copy paste this one signature starter template. Just give me a second. So let me come here. So yeah, let me paste it over here. So this is fine. Just ignore this one. Just concentrate on the logical part. So now let me come here and let's try out with the first input. So we have to get the output 1 here. So let me paste it over here. Let me hit the run button. So we have this error. What is the error? Yeah, we have to give comma here. Instead, I have given semicolon here, right? So line number 24, this one has to be comma. This is fine. Let me hit the run button now. So many errors, man. How many errors we have? 4 errors. Okay. Error cannot find the symbol. Uh, this one reversed of I symbol. What symbol we have? Method reverse. Why? New string builder strings of I dot reverse. So we have the reverse, right? So what is the problem with reverse here? Line number what? Just give me a second here. Line number 51, right? So here, mm, So yeah, what mistake I have done here is I should close the parenthesis here, right? Strings of I dot reverse, entire thing we have to reverse. So I have closed the parenthesis here. I'll delete parenthesis here and let me close it here. So we are reversing the entire string, right? So this one has to be reversed and then we are converting to string by making use of toString. So this was wrong. So let me run this one again. Now this has to work. Yeah, now we mm, those two errors are gone. Now let's concentrate on the last two errors. What we have here, bad operand types for binary operator. This one, line number 75. Where is it? We have here. What is wrong here? Basically, bad operand. Just give me a second here. Bad operand types for the binary operator less than or equal to. If visited of this thing compared this one. Yeah, let's check. So yeah, again I have done the same mistake actually here. See, in the line number 79, I have closed the if condition here itself correctly. Whole thing we are checking less than or equal to 0. Here I have closed the this one parenthesis here. This has to be here. Misplacing the parenthesis basically. I have misplaced the parenthesis. So here I have to close this one, closing parenthesis here, not this one, right? So we are comparing entire thing less than, I mean, checking whether entire thing is less than or equal to 0, right? So now this has to work. Let's see. Now we have one error. The last error what we have, cannot find the symbol variable cost. So we go to this one, line number 80. We have made use of the current cost, right? So this is fine. Cost we have. mm, just give me a second here. So yeah, this one, because we have made use of the costs, I think, not the cost. Just give me a second. Yeah, we have made use of the costs. So, um, long costs, right? So I have misspelled here. Let me make this one cost. So just give me a second. Why did it take entire thing? So let me give here s. Let me add s here. So now this error has to be cleared. Just see. Yeah, we are getting the output one, correct output, right? So let's try out with a different input. So I'll just come here. Let me copy this one. Again, we have to get the output one. Let's check this one. So we are getting the output one. We are done with the two inputs. Like let's check two more. So for this one, we have to get -1. So here we have the -1, the final one, the final input. Let's copy this one. Yeah, let me paste this one over here. If I run this one, we are getting -1, right? So this is fine. So the code works absolutely correct for all the inputs or all the examples that they have given in the question. So let me copy this one entirely and let me paste it over here. So this is question C, right? Problem C. So let me choose the C, hard problem, from the drop down, and let me hit the submit button. So I hope this works for all the test cases, man. Let's see. I hope this works for all the test cases. Let's see. Let's wait for some time. So this is taking time here. You can clearly see. Oh, this is very slow. So let's wait for some time. Running on test one. So let's wait for some time. Running on. So here you can clearly see. Whatever the code that we wrote got accepted, means whatever the code that we wrote works absolutely correct for all the test cases. So just give me a second. So yeah, this is very slow, man. I don't know what happened. This is fine. So I hope the solution part is completely clear. I hope the solution part is completely clear. We went with the priority queue with the greedy, basically, right? So I hope the solution part is completely clear along with the approach and complexities, right? For now, this is it. Thanks for watching, guys.